Okay, so let's talk a little bit about polynomials. End behavior means what happens as you go off to infinity. So the best way I think to remember it is to consider two things that you know. You know what a line does. This is a positive slope, so if I have mx plus b, m is positive, m is negative. If I have ax squared with a positive, it opens up. I really should have gone across the axes there. Ax squared, if a is negative, this is all you need to remember really to figure out end behavior. Any polynomial with an odd powered leading term is like your favorite odd power, x to the 1. So the end behavior stuff happens in the middle. There's a bunch of wiggling, but if the first term is positive coefficient, then it goes like that. And if the first term has a negative coefficient, then it goes like that. With even leading terms, even degree, if the leading term has a positive coefficient, they both go up. If it has a negative coefficient, they both go down. Okay, so we look at this one. We want to know the end behavior. This is the leading term. So it's got an even degree, which means they both go the same direction, and it's negative, so they both go down. Okay, so we want to know what is a multiplicity. I'm going to use this question to kind of answer it for you. So once you've gotten everything all nice and factored out, you could look at this and read off the zeros. Things which make it 0. If x to the 4th is 0, x is 0. If x plus 2 is 0, then negative 2 is a 0. If x minus 1 is 0, x equals 1 is a 0. Zeros, so if x to the 4th is 0, I'm looking for the zeros of the function. That means the intercept. So zeros of f means all x where f of x is 0. So this is another way of saying I'm looking for the intercepts, the x-intercepts. I could also say I'm looking for the roots of f. These are the same thing. Sorry, this was cute. So if x to the 4th is 0, I take this all to the 1/4 and I still get 0. If this equals 0, then I take it to the 1/3 and x plus 2 is 0. Go ahead and move over that 1. So these are our 3 zeros. They're just, if you see x to a power that's 0 is a 0, and everything else you swap the sign. The plus 2 means it's negative 2, the negative 1 means it's a plus 1, because that horizontal shifting deal. Okay, so these are the zeros. So what is a multiplicity? This 0 came to us by way of us having a power on x. Whatever that power is the multiplicity. So if this just said x, it would be multiplicity 1, but it's to the 4th. So multiplicity 4. Just the power on the part of this that made it the 0. Negative 2 was made 0 by the presence of an x plus 2. There are 3 x plus 2's. So this has multiplicity 3. 1 became a 0 by virtue of x minus 1 being in our product. X minus 1 is only there one time. So that's multiplicity 1. It has 3. They are 0, -2, and 1. 0 has a multiplicity 1. -2 has a multiplicity of 3. Oh, sorry, 0 has a multiplicity of 4. The wrong place. 1 has a multiplicity of 1. Okay, so this one we want to determine the minimum degree. So what happens is that if you have, say, 1 degree, so like x, you just go straight. If you have degree 2, you turn around once. Maybe that way, but you turn 1 time. If it's x cubed, just x cubed, it doesn't turn around at all, but if you add some stuff, then it does twice. So whatever the degree is, you have 1 fewer turnaround points, and it's really down to, this one can only have 1 0, so you can't take the chance of crossing back over. This one can have 2 zeros, so you can cross back over the axis at most 1 time. This one might have 3 zeros, so you can cross 3 times. So if you had, say, x to the 7th and then blah, 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 it's possible that I could cross once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. So I end up with 1, 2, 3, 4, 5, 6 turnaround points. So if we look at this one, the minimum degree is 3 because it's got 2 turnaround points, so I have to have at least 3. The leading coefficient is negative because this overall has a negative slope. It starts up here and then goes down there. The degree of the polynomial is odd because they go off in different directions. If the arrows are pointing in different directions, then it's odd. Not an odd function, an odd degree function. And then we want to guess at what those zeros are, and if their multiplicities are even or odd. So the reason we cared about those multiplicities is every time you have a 0, you change sign. So if I have zeros, say I have x minus 2, x plus 1, x minus 1 squared. Say that this is what I have. Then I have a 0 at 2, and I have 1 at 1, and I have 1 at -1. But I change sign, so I change sign at -1, and I only change sign once, so I pass through it. I have to pass through it. And then I have to come back down to hit this one. But at 1, I change sign 2 times. So if I changed once, I would go negative, but I changed twice, so I actually have to stay positive. So I just kind of bounce off it there. And then at 2, I change sign only 1 time, so I really change sign. So this is the same as -1 to the blah, what kind of sign change you get. So if it's an even multiplicity, it bounces off. And if it's an odd multiplicity, it passes through. So that's why we care about the multiplicities at all. So we're trying to figure out, well, so the first thing is it can be a polynomial function. It looks like it probably is cubic. The minimum degree is 3. So it could be 5. We could have some extra x's running around. It could be any even amount above 3. The leading coefficient is negative. Again, just because it's going generally downward and it's an odd degree. The degree is odd because they go opposite directions. And then it has 1, 2, 3 zeros. We want to approximate the zeros. That looks like 2, -2, and -4. Okay, now this wants us to just decide if it's odd or even. Let's go back and look. I passed through here, here, and here. Because we passed through on every single one, they're all odd. So you have to bounce off the axis, bounce off the x-axis for, oh, what? Oh, this should have been -4, I didn't type it. So odd multiplicities all around. That's very strange. I don't know how that happened. I guess you can rewind it and look, but I said all odd, so weirdness. Okay. 25. So our goal is to sketch this. I'm going to go ahead and copy it just in case we want it later. The end behavior is, it's an even degree. If these were in the other order, I mean, this is all even, but you want to find the one with highest power. So if it's written out of order, it's not descending in degree. You want to still find the one that has the highest degree term, because that's what controls end behavior. So it's even, that means they go the same direction. Negative means they both go down. Okay, we want to know about the y-intercepts. It should have 1 or none. If I plug in 0, I get -8, so it has 1. Okay, so now we want to know about zeros, so I do want this. I could just do the discriminant to see how many there are, but I have a suspicion it's going to ask me what they are. So I'm going to say let u be x squared, because I have a quadratic form here, it's just to the 4th n squared, but since they're the only ones besides the constant, I can do the substitution. So b of u is minus u squared plus 6u minus 8. Remember that I'm not a fan of having the negatives. I also don't like them leading my polynomial, so since it was equal to 0, I just changed everybody's sign, basically divided by -1. We want things that multiply together to give 8 and add together to give -6. That means they're both going to be negative. So u equals, well, so u minus 4 equals 0, or u minus 2 equals 0, u equals 4, or u equals 2. But remember, u is x squared, so x squared equals 4, or x squared equals 2. X equals plus or minus 2, x equals plus or minus root 2. All of those are real. So now we want to decide which of this it is. So we're looking for a y-intercept of -8, which rules out these two. Could be this one. I feel like that's too close. I feel like it can only be this one just right off the bat from that. But anyway, we know that it should be going down on both sides. So that's one of these three. We know that we have a y-intercept of -8, which theoretically could be either of these. We know it's even, so we could rule it down to these actually. But let's look at the zeros. So we want zeros at 2, which may be there. 2 and -2, that is. This does not have 0 at -2. So now we're down to one of these two. And then the other 0 is at √2 and -√2, which is a little bigger than 1, like this one has. And maybe this one too. So I think between these, the only difference we can come up with is that -8 should be about half of -20. So that one's way too high. So that one. All right, one more. We want to graph this. It has 1, 2, 3, 4 zeros, each with multiplicity 1. So that means it's degree 4. So both end behaviors are the same direction because it's even. 1/60th is small, but it's positive, so they're both going to be going upward. So it can't be those two. It's got to be one of these two. We need zeros at 17, -6, -4, and +5. We can also find the y-intercept, and that would actually clear it up because these have very different scales. Probably it's this one because that 1/60th makes things pretty small. So I'm going to talk about it a couple of different ways. I am going to go figure out what the y-intercept is. But also, we want that 5 and 17. This seems reasonable. If this is 5, that's probably 8. So I don't think that that's far enough apart. And then -6, -4, that maybe, well, that's -1. So all of these zeros are less than, they're between 1 and -1. So it can't be this, so it will be this. But just in case that wasn't the situation, if they made it a little more similar, the y-intercept could be found. Give 0. So those negatives cancel. 20, 120. The reason I multiplied these three and kind of stopped is because 120 over 60 is 2. So the y-intercept is 34, which is not the case here and is the case there. It looks a little higher than 34, but I assume it is. So it should be B. Okay, so that wraps up this section.